Alright, the purpose of this video is to review how to make mental sketches of quadratic functions that are written in this, which we call standard form, ax squared plus bx plus c, which looks like this, ax squared plus bx plus c. Whenever we see a function like that, we should understand that all of the solutions to that equation are going to fall in the shape of a parabola. Ours is to figure out how that parabola is going to be oriented on the graph. To begin with, we're going to look at the fact that every quadratic function begins with a linear function which has a squared part that's added to it. So for example, we could start by looking at 10x plus 20 or 18x plus 23 or negative 6x plus 11 and then studying the effect that the x squared or the 3x squared or in this case the negative 1 half x squared has on the curve. So to look at that in more detail, I want to look at this. This is the line y equals 3x plus 2. It's that brownish green line. And I'm going to add the parabola with ax squared plus 3x plus 2. And what I'd like us to do is to look at what happens when I add x squared values of any multiple to this line. And what we see is the line curved up. I wish I could make that happen a little more slowly. I can, but it's too late now. Here we can basically see that the line is curling upwards. So realize that this, for example, is a picture of the line y equals x squared plus 3x plus 2. And notice the line y equals 3x plus 2 goes right through the y-intercept, and it has the same general behavior as the parabola does. And you can zoom in there, and when you zoom in, you see that the line and the parabola are virtually the same. But because of the addition of 1x squared, x values that are further away from 0 cause the line to be, again, in this case, curled up. So the idea is the parabola started as a line, but those positive x squared values caused the line to curl upwards, so it's a parabola opening up. Now contrast that with negative x squared values. Here we have the same exact line, and again, zoom in, it looks like they are the same line almost. The closer we get, the more it looks like it's the same line. But because I'm taking squared values and then multiplying them by a negative number, that causes the positive values of the line to curl downwards. So once again, we start off with a line. All the positivity is being made negative because of that negative x squared value, and we get a downward parabola as a result. The bigger the a value, the more rapid that parabolizes. All right. Now, the only other contrast we could have here, let's set the a back to 0, is what if we had a decreasing line? So we have y equals negative 3x plus 2. Now, if I was to make the a value positive, that would mean the parabola has to open up, which means we're going to have to curl all this negativity up into positivity. So let's see if I'm right. Positive a values, the line curls up to make that parabola. But notice the line, minus 3x plus 2, is still retained. It's just that the line has to curl up as we get further away from 0. Negative x values, or negative a values rather, cause the top of that line, all that positivity, is now going to curl down and become negative. So let's put that into practice. I have 6 different functions, and I just want to see if I can piece together the general sense of the sketch. So I could start with, and again, these are crappy sketches, so it doesn't really matter. Oh, not that crappy, but we'll see. I'm trying to draw with a mouse, not so good at it. Let's try that again. There's our y-axis, there's our x-axis. We're going to cross at 20. We're going to be rapidly increasing. And all the negativity is going to be curled upwards to become positivity. And all the positivity is going to get more positive. So that's how this parabola is going to look. Now, how low it dips and when it turns around, we have analysis to figure that out. But for at least in terms of the mental sketch aspect, we start with the line and we work our way from there. So here, once again, we're above the x-axis, we're rapidly increasing, but all the negativity is going to be turned into positivity because of this a value, and it's going to happen really rapidly. So we're going to get a narrower parabola that way. All right, now contrast that with this line. We've got positive y-intercept, but this time the line or the initial values are decreasing, so we're going to have a line that looks kind of like that. But positivity, all the negativity is going to curl upwards, curl up. So that's, again, mental sketches. Now this is really bad scribbly mouse drawings. Let's see if I can make some of this go away. And without talking so much, just looking at the next one, if I had this one, I would look here, there. This is positive, so I'm going to be crossing this way. And this is negative, so it's going to curl down, but still maintain that spot through the line. Here we go. Across below, we're decreasing and curling down, so it's got to be curling down. This is the general shape of that parabola. And finally, we are below, but increasing rapidly and curling down. So that's generally how you make a mental sketch, and these sketches are really terrible, but they're giving me a sense of the orientation of the parabola. We're opening up or down and dipping to the left or to the right. I hope that's helpful. If it's not, please feel free to ask me again. But that's how we make mental sketches. Now, just so you know, the purpose for making the mental sketches, we are going to look at finding the values for the axis of symmetry, which will give us our vertex. And if we calculate our vertex, it should be consistent with where we thought the parabola was going to dip. I imagine the parabola is going to dip to the left, then my vertex should be to the left of the origin. If I imagine the graph is going to dip to the right, then I should expect my vertex to be off to the right. So the purpose of the mental sketch is to give a sense of where the x-intercepts should be if they're going to exist, and where the vertex should be, and where the parabola should be in general. So it's an important skill to keep in mind. All right.